How's it going, guys? So my name is Steven. I've actually learned Node only a few months ago. And what's interesting is that I always see all the contributors and such on GitHub and things like that. And I never actually get to see anybody's faces. And when I shot out this talk to Michael, I didn't really think I had a chance in hell of ever getting on stage. So I am. So it's fantastic. I'm really excited about that. So the title of my talk is really like the hacker's guide to IoT with Node. So a few months ago, earlier this year, I decided, hey, let me create a project. Let me do something fun and cool, and let me try using this Node thing that that I hear is getting really popular. It's getting really exciting. I'm sure you guys all know. And the cool part about it is that it seems like nowadays everything just kind of runs on JavaScript. From a variety of devices to things that you just really wouldn't expect, cloud automation, things like that you just wouldn't expect besides the web server and what you would normally use it for. And so I just kind of wanted to share a little of my experiences that I had and the things that I did to kind of get myself off my started up pretty easily and a lot easier and quicker than I thought I would. So I guess before I go too far into that, nobody really knows who I am because it's probably my first time at a NodeConf. I guess I'll talk just a little bit about myself. So I usually describe myself as three things. The first thing is developer advocate. Yes, yes, yes. I always have to say, you know, I work for a company that rhymes with something soft. And yeah, so I do a lot of things that are outreach, developer advocacy. I call it trying to make developers' lives easier. And where I can, I try to use our products. But that's my business side, and that's not just all of me. So besides that, besides trying to help developers be active and try to make their lives easier and helping them one-on-one, I also just like to build cool shit. I get paid to build really cool things. It's really fun. For example, at TechCrunch Disrupt, we did an IoT project there where we won $1,000 just for connecting Twitter tweets and launching a rocket. Like, literally, that was it. I just stood up a Node server, collected some Twitter tweets, sent it down to this little chip that I'll actually talk about a little bit later, and able to just trigger a pin that fires a relay that fires a rocket. And you know what? People really like rockets. Like, that's like something I've learned. Like, if it goes boom, people like it. The other thing that you actually see there is a T-shirt can that I made. It's also a very similar idea, pressurized stuff. Hit a relay. It's also augmentative connect, so it follows you of heat sinking and all this crazy stuff. Yeah, it's actually pretty insane. You could check my blog. It's really neat. I got on TechCrunch for that. It was really fun. And besides that, the last thing I like to call myself is a life enthusiast. I don't know what that means. I've been keeping on my Twitter handle for a while, so I figure I might as well try to explain it. But essentially it just means anything that's new, interesting, fun. I love to travel. I love to just try new things. And so I just figured I threw some pictures up. I think one's in China, others in Rome, and I actually just got back from Japan a couple of days ago. So I feel like cutting the bullshit because IoT is like this cool buzz phrase, but it's not really like anything new. It's really not. It's just the same stuff we've been doing with hardware, with resistors, and all of a sudden someone just decided, hey, why don't we just start doing web requests? And that's really what kind of where it started up, right? Things started to get a little bit smaller and smaller and smaller to where it kind of got reasonable and feasible to be like, well, why don't I just make a HTTP request? And the thing is, before runtimes and things like that were on small devices, doing that in C++ native code was kind of a pain, but now that we have things like Python and Node that runs on devices that are reasonably small, you can actually start to think of really cool scenarios. So this Internet of Things really is just the fact that we can run modern languages on smaller devices and also connect those to cloud services that are actually relevant and allow us to do things pretty much turnkey. There's like this real big jump that's been leaping with the easiness of being able to stand up your backend, and the same thing's actually going on the hardware side too. And the interesting thing is that I'll talk to developers, and some of them will say, well, I don't really know hardware, or I don't really touch hardware. And the funny thing is that it's the same thing with having, like, for example, parse backend for like your mobile apps. That's such a turnkey solution. It makes it really easy to understand what tables are and how, if you even never learned databases, you still kind of get it, right? It's the same idea with hardware. The things that are moving in hardware to make things so much easier to enable the traditional developer, the non-hardware developer, to understand, well, here's how I interface to this thing. Here's how I take this thing and connect it to the internet. That's what it's all about, right? That's why it's called IoT. You take this interface, either it's a digital interface, the analog interface, and you essentially just hook that up, interact with it, and then send some data over to the cloud. You take that data in the cloud and you're able to do stuff with it, such as real-time analytics. You could do machine learning over that data. There's tons and tons and tons of stuff you can do with that data. I'm sure you guys are wearing smartwatches. I'm wearing one too. And the way that you get to the internet doesn't really matter as long as you can just get to it, right? It could either be through your phone or it could be through a Wi-Fi hotspot, whatever it is. So I always start with just the basics because I don't know who knows what, and this is not like a deeply technical talk, but it's more of like the basic. If you've never actually done hardware before, has anybody not done hardware before ever? Okay, so it's really easy. So there's a concept, and this is just square one. There's something called GPIO. If you ever just want to do hardware, it's so easy. These GPIO pins allow you to do two things. You can either send a 1 or a 0, or receive a 1 or a 0. And you could do it over a variety of bits. So if I have 8 bits wide, I could get 1s and 0s on each of those, and guess what? Now I have a byte, right? So it makes it pretty easy, but even before that, even if you go back to one level, you can send a byte, or you could send a bit, which can say, okay, well, turn this LED on, or fire this t-shirt cannon, or do all these interesting things based on whatever happened on the internet. Think about that. When we did the rocket hack at TechCrunch Disrupt, which had no actual value besides the fact that you're blowing shit up, right? It's fun. And it's like, well, you're able to say, well, look, guys, tweet this tweet this hashtag, something that's happening online is completely non-related, at least from a physical sense, and take that and say, well, now just flip this LED or flip this signal. That's all you need to do, right? Super, super simple. Same thing with reading. Coming on the input, and what we'll talk about is the project I built, where it's super, super simple. You receive a 1 or a 0. You receive a 1, something interesting happened. Well, what happened? Depends on what that 1 or 0 is plugged into, right? It could be plugged into a button. It could be plugged into something where someone walked by and there's a motion sensor, but you know that something interesting happened. Well, now what if you have thousands of those things and those things happen? Well, let's look at this conference, for example. We can easily just take a digital sensor and see, okay, well, how many people walked in and walked out? Take that, plug into the cloud, you get something interesting. So this is kind of a slightly deeper dive, but so what we've done, what I did was I worked with the Raspberry Pi, and we'll talk about just a couple of devices in a sec. But when you're looking at it, it's just basically a pin. And like I said, you can just turn it as an input. Input reads the 1 or 0, outputs the 1 or 0, and you could line up as many of them you want and kind of turn them into to a bigger number or smaller number depending on how many bits you need. So there's really 3 types of pins you want to worry about. I'm not going to bog you down with serial communication or those types because they're a little bit more complicated. But from the basic standpoint, you have a resistor, you have an LED, and you just plug it into a power supply. There's also a ground supply, and then the third one is your GPIO pins. So that's why there's kind of 3 types of pins here. And really, it's like you take the volt pin and it acts as a ground, and you take the other one, you plug it into the GPIO pin, and say you put it as an output. And if you put a 1, you get a high voltage. Put a 0, you get a low voltage. What happens when you put a high voltage on this little circuit here? Well, it's just going to turn on the LED. And I promise that if you just know this, you could really just get started. It doesn't require anything more than that. Okay, so next. Well, we've already got the internet part, right? So it's the thing that connects the things. The GPIO connects those things. And now we just got to talk to the web. So, how do we go about doing that? Well, before it was a little difficult because we didn't have like sexy languages and things like that. But now we're lucky to have the fact that on a lot of devices today, JavaScript runs on it. And not only JavaScript, but Node. So then you have your whole package, your whole community of packages that will come with that. Now, not everything's going to be compatible everywhere, right? You have different architectures. Some modules are native. They might not build correctly. But for the most part, if you want the async library, you're going to get it, right? If you want your date time, you're going to get that. You get all this basic stuff that just comes out of it. You don't necessarily need to learn how to, parse the streams coming in and out of an HTTP request. That makes it a lot easier. So now, all of a sudden, you could do the same code that you do on your server on a little tiny device. And what's even cooler is that because JavaScript runs on these devices, this is the coolest sauce. is that you can simulate those programs much easier on your computer. Why is that important? Well, debugging is always great and things like that, but let's think about it a step further. Say we have all these little devices that are giving us this data. They're giving us this little data, giving us this little data, right? Well, how many devices can you possibly have and pay for to actually test that backend? That gets expensive, right? So what if you took a console application and just said, well, I'm going to simulate, and the thing is with the Raspberry Pi, and what I'm going to talk about in a bit, you can actually just control those GPIO pins with just a file system. Well, all of a sudden it became easier because guess what? I could simulate a file system on my laptop. So now I can take this program and I can multiply it times thousands, times millions of devices if I wanted to without actually having to pay for those devices, run them in the cloud or run them on my computer, see how things react, right? All of a sudden now you have load testing. On the same, something very similar to what you'd have on the device. So this is why it's really cool. It's not just because it's easier, but it actually allows for the simulation, which is really neat. So this is how easy it is, really. Like, if you're scared of it or if you're thinking it's lame or whatever, the code really just gets this simple. I think I'm missing one line for brevity, but that's about it. So some devices that are kind of interesting that you can use. So when I won TechCrunch this week, I don't want it, but I got a good chunk of change out of it, so it's pretty neat. No applause. I'm just saying that you could actually do something simple and impress people. So the first thing is we actually went with the Spark IO, and so these guys are sponsoring the hackathon. I really like these guys. Super nice, helped us out, and so basically they have, and it's like Electric Imp, I think, does this as well. How am I on time? Okay, good. So Electric Imp does this thing as well, and essentially it's like this integrated cloud, right? And it'll be actually I'm going to talk about what I did. It'll be kind of like, well, that comes out of the box. But these guys are, selling an open source, open platform, really tiny device. Now they just recently dropped it to about 20 bucks, right? So 20 bucks, still good. You could buy about 10 of those and you'd still be all right. Excuse me. And what you're able to do with this thing is you're actually able to take your JavaScript, write it in the browser, and click send. And it just sends it to the device. And then all of a sudden you have this back and forth conversation, this communication with your device. And then you can just pipe that up to your server and do whatever you want with it. You can buy 100 of these things. I could put 100 of these under your seat, and I could tell how many people are in the room at all times, always, from anywhere on the web. Kind of neat, right? So this is kind of a really cool thing where it's just easily messaging right out of the box. There's a variety of shields for it. It's great. I like it a lot because if you're at a hackathon, it's about the fastest thing to get up and started. Now, say that you're super open source. You're like, you know what? I don't want to use a proprietary cloud. I don't want anybody's thing. I want to do what I want to do. This is what I picked. Why? It's a lot more powerful than that Spark IO. Just to make that clear. It's a cheap device, but it's not a cheap device. It has a lot of power, and for the project I did, and I'll demonstrate in a bit, it's actually way overkill. But the cool thing is say that you want to just get into this space. Well, 35 bucks isn't much to spend on something that can basically do anything you want. It's a full Linux build. You could put whatever you want on it, as long as it kind of works for ARM. You're pretty much fine. You can run Python, you can run Node, you can run C# even. You could do a variety of languages on it. There's no opinion to this thing. This thing doesn't care. Now, what you don't get out of the box is that integrated cloud. You don't get any of that stuff easy. But at the same time, nowadays, there's all these services, that make things easy that it's not even that bad. So relatively cheap. It's non-opinionated. I like it. This one's just worth mentioning. Intel's been doing a lot of pushing on this as well. This is basically a miniature x86 box. If you really like Windows programming, I think this is like the go-to, just because, hey, it's the same thing as your device. You could debug it, you could do whatever in Visual Studio, and you could push it on there. Just depends on what you like. If this is your flavor, if that's your no-world dev environment, it makes you feel a little bit more like home. So if you guys are curious, and I really should put this toward the end so you guys could see the project I built and be like, oh, how do I build that? But basically, I bought this thing, about 75 bucks. I think it's probably a little cheaper now. But it's great. It's a little Raspberry Pi kit, has a bunch of stuff to it, everything to get you started besides the camera. But I'll tell you what the project I made, but essentially it comes with that breadboard to make that little circuit for you. If you just look up a breadboards go horizontally in the middle, vertically on the edges, so that the connections can be separate but very easily prototyped before you actually bake that onto a board. So that's actually what happens. So you prototype on this thing, And if you really want to ship this thing out, you would take that circuit on that board and you would essentially put it on an actual green IC chip, and you have to send that off and get it done, so it's quite expensive. All right, so step one. So this is not really much different than what you think about when you think of hacking, right? The cool part is with IoT, though, you get to, like, instead of like, oh, I'm going to take this API and this API and mash it up, and, oh, bro, look, I have a butler that'll order Uber for you and all that, which is cool, it's great. But you could also do, I'm just making fun of like hackathons because I see that all the time. Sorry. So instead, but you could take other like stuff. You could take this random shit and just put it together. And that's the coolest part, right? So the first step really is to think of two things that just really shouldn't be integrated together, and just integrate them together. Just fuck it, right? Let's do it. So it's great. It'd be fun. Now, so actually my colleague, how am I doing on time? Okay. How's my, do I have audio at all? So my colleague up in New York, she made this really cool project, which is basically this processing app, which processes things like this platform that you can, I think it's an open source platform you could stand up in your own server. And you could use it for like sending things back and forth, so it makes it really easy. So she made a dubstep Skrillex, which Skrillex T-Rex thing. So I got to jump out of here really quick. It's a Vine, so you know it's going to be short. Oh, geez. All right. A little dubstep, a little visual dubstep. All right. Oh, no. Oh, and you know what, Michael? I don't think I'm on the internet, so, oh, that's not going to happen. All right, well, I do. I mean, I have some wives.
What the fuck is that? Here, hold on. Let's try this again.
You got some internet, yo? Can you share some? Break me off a piece? What the hell, man?
Taco net, you see the taco. Oh, yeah, there it is.
Where? Taco net, there we go. All right.
It's like between the two.
Oh, wait, what was the password?
Pizza cats.
I don't know why I just invented my own password.
P-I-Z. Oh, wait.
Lowercase? Or?
No, wait, don't show password. Don't show password. Don't show password.
Show the password.
P-I. I'm like a security risk, right? I should.
Okay there?
Oh, man, this is like an AV nightmare. Holy cow. All right.
No, it's not there. It's not there. It's actually at the projector.
Oh.
Yeah.
Who's like the fawns?
Fine.
Can someone just knock there?
It's only 6 seconds. Yeah.
Yeah, it's not a big deal. I'm just hoping that this doesn't happen during my slides, because then, well.
What you're saying is hardware is easy. With JavaScript it is.
Crap, why isn't it playing now? So this is my colleague Stacy. So she made a T-Rex with Arduino Uno, and basically you can take this T-Rex and basically drop the bass when your song's playing. And it connects through, like, I think it's connecting through Azure, but she's running the processing service in the back end. And essentially, as she's doing that, you don't have the sound, but she's top left corner. Let me see.
Is that the output? Or is that the...
Yeah, on the bind itself it's muted by default.
There we go.
I want to introduce you to Skrill T-Rex. And drop some bass like it's Skrillex. I want to introduce you to Skrill.
So, anyways, so that's a good example of like, that's just weird shit, right? It shouldn't really be put together, but it is. So, yeah, so that's kind of what I'm getting at here, is that you don't necessarily have to have anything that kind of makes sense, just to have a little bit of fun and kind of demonstrate some core concepts that you need if you're trying to actually make something serious. Okay, so how about, okay, so for step 2, so let me go back to what I made. So we can actually talk about, I think I have the device here too, but I'll do the video demo because that's always demo proof. The demo gods are always with me then. Except now. All right, let's see. You think so? All right. All right. Let's see. Might be the frequency too. Let's see, how does that look? It says if screen goes black, and it did, but there we go. Amazing. Okay. All right, let's see. Can I get to this here? If not, just have to go to my website. It's fine. All right, that's fine. Okay. Okay.
My name is Steven, and this is the SmartDoor device. SmartDoor device is a Raspberry Pi with a doorbell actually attached to it. There's also a camera on it. And what this does is kind of simulate the fact of having your doorbell at home and having your smartphone on you. And what will happen is that when I press the button, it'll take a picture, put it on the doorbell, and it'll tell me on my phone who rang. It'll also check the face and tell me the name of the person if that face is recognized. So to do it, all you have to do is go ahead and press the doorbell button, and then within a few seconds, I'll get a push notification on my phone. I can show you right up here, and it will give you a notification of who rang my doorbell. And if you slide down, you'll see that it says Stephen Edouard just rang. For good measure, I have my colleague here, Christine, who will also show that it's not just my hard-coded name, it works on you.
This is just to show I'm not cheating.
So Christine's face has been trained on the server, so it knows about Christine's face. So now when Christine rings my doorbell, my friend does, we'll also get a notification that Christine rang, and they'll say Christine Matheny just rang. So that's about it. It's a pretty easy scenario. Anywhere in the world, you can see who rang the doorbell.
So what did we just see there? So that was actually kind of neat. So the idea was that I basically sign into this app on my phone, and it's not an idea, it's actually how it works. I look at my friends and say, okay, well, you know what? They all have Facebook profile pictures, so why don't I collect all the profile pictures? Profile pictures generally have faces, all right? Take those faces, run them through a facial recognition API, just some random one I found on Mashape, and then connect it up to my backend service on Azure and be like, okay, well, let me go ahead and just crunch over those faces and tell me who that person is that rang my door. Well, how do you know that? Well, we press the doorbell, and it pulls that. Remember how we had an input line? Well, that input line gets pulled high when I press this thing. The software knows that it got pressed, it got pulled, so that signals it, takes a picture right through here. Super duper easy API on the Raspberry Pi to do that. And then just as easy as that, you basically talk to some endpoints that's up in the Azure cloud. Why do I use Azure? Well, I work at something soft, so it's really easy for me to use it, but it's also a pretty good service because it's scalable. So now the architecture remains the same no matter what platform or cloud you're using. So you can talk about like, hey, well, what's under the hood here? So the idea is that it's easy to do two-way communication with a lot of platform services as well as your own like open source services. You could do this with Redis too if you really wanted to. But the idea is that, okay, well, I have a queue in the cloud, and I'm able to take this queue and take a variety of different devices and just hook them up. Just hook them up to the cloud. And then what they can do, instead of standing up my own API that's just dealing with that, I can just create a web task that basically listens to this 24/7. Says, well, let me listen to all these things that are talking to me. They're all talking to me. I could scale and scale and scale. As the more messages that comes in, more scalability, well, you just toggle some knobs, the typical elasticity of the cloud that you get. And essentially, you can take this data and you can throw it in. You could throw it in with this service, and the service collects those little JSON messages and does something interesting. In this case, we take a push notification, we run it through a facial recognition API, we also stuff it into a database. So not to get too boring or too into technical gritty, but basically we take those service bus service bus queue, which is what's called a Microsoft, but it's the same idea. We take a queue and we take a storage and we say, okay, well. The first thing I'm going to do is I'm going to go ahead and put my stuff into storage, and we'll talk about that in a sec because that makes a lot of difference. Then we're going to notify it through the service bus, and it's going to push the node service up in the cloud, and it'll say, okay, well, I got a notification, so let me go ahead and throw this up into facial recognition, some MoShape API, get it down. It says, okay, well, I have some confidence that this is a face, and I know who this is. So now let me go through Notification Hub, which can send push notifications, and it's actually cross-platform, so it works pretty well. And then I can say, okay, well, here are the devices that are registered for that person, and here's who rang your doorbell. Pretty simple, right? And we stuff it in MongoDB just to have a database of the history of people who rang the door. Now, what's really cool is that, and it's something I learned that I wasn't actually like super aware of, but it was kind of actually enforced by the service to me, was that, and you know, this works for web services too, or any type of application, backend application with like some client, is that you want to stuff all your binary stuff into like S3 or the equivalent, which is Azure Storage, because if not, then, well, well, you're gonna block up your server, right, on these uploads. You're gonna keep these sockets open, and there's no reason to do that if you could just take instead a key from your web server, say, hey, can you please just give me a key, and then I'll go ahead and just go to the storage warehouse, and they can deal with that traffic, right? They could deal with those uploads because you don't want to deal with that. Again, what happens when you scale to thousands and millions of devices? Well, then you hit this issue of, well, now you're paying to run these servers that are just hanging on uploads. Well, that's kind of lame, right? So instead, you just go ahead and throw it into the storage directly, and then you just free things up for just like JSON and like light messaging like that, so you kind of reduce the chattiness there. And so that was something cool that I learned, and I didn't realize, like, well, that makes sense, is how you do it. So you connect it directly to storage for scale, and really, so the key learnings that I had were that, you know, this message queuing paradigm is actually pretty awesome, because it makes everything a lot easier, as far as you can even do two-way messaging. If I wanted to open that lock, all I simply have to do is go from the cloud and say, well, hey, service bus, can you tell this device to do this signal? And what that would look like in the hardware is, again, I'd have just, instead of an input, I would have an output GPIO and say, well, hook that up to what we call relay. The relay is really simple. It's just, hey, can you relay this really big, just take this small piece of energy, which is really just a 5-volt line, and relay it to like a 1 amp signal to just crank open a lock. Super easy. It's like actuate or whatever. The next thing is cross-platform runtimes, like Node.js, Python as well. Like, those things make it really easy to go ahead and say, I'm going to simulate this thing across devices. I'm not just going to have to do it. I'm not going to just have to buy 1,000 devices and see how it works. It's actually super easy to create just alternate builds between your device version and your actual computer version, so that you can run these things in the cloud, so you could actually just test things out before, you know, buying 1,000 devices and, you know, being out of money. And finally, the last thing is really just offload your data uploads. That was something I learned pretty quick, was, well, if you already have a massive warehouse cloud service, which nowadays that's what everybody has, it's a lot easier to stuff your stuff up there, call it a day, and just be easy with it. So, and that's pretty much all I have for you. I wasn't going to keep it too long, but I'm hoping that this kind of inspired you to kind of build your own shit and be awesome and have fun with hardware, because this stuff is easy. It's become democratized. It's become easier because we have things like Node just running right on the device, which looks exactly like your server. So thanks again, guys. I really appreciate you guys welcoming me here and having me talk. Whew.